Hi, let's solve today's daily challenge, that is group anagrams. So here we are given an array of strings, as you can see here, and we have to group the anagrams together, and we can return in any order. So first of all, let's understand what an anagram is. So here in the question it's also written, it is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Let's say I have a string A B C A D, right? And let's say I have another string B A C D A, right? Now, what is common in both of these strings? It is just that this particular string is made using all the characters that are present here, right? So we have basically rearranged these characters to form this string. So these two strings will be called anagrams of each other, right? Similarly, if we take eat here, right, so I can see we have E A T. So I can write any string, like let's say I write E T A, or I write T E A, or T A E, or A T E, or A E T, right? So all these strings are anagrams. So basically it's like a permutation of a string, right, of a given string. So all these permutations are called anagrams only, right? So I hope you've understood what anagram means. Correct. Now let us proceed with what we have to do in the question. Okay, so in the question we are being told you need to group these anagrams, right? So you are given some random strings and you have to find out the anagrams. So all right, so I have EAT, correct, and I need to find the anagrams of EAT. So from here I can see this is T and 8. So T and 8. This is, these three are anagrams, so we have to group them. Correct. Now I'll move to next one, that is tan. So if I see tan and nat, right? So this nat is just a permutation of tan, correct? So I can say tan and nat, these are anagrams, so we group them. Then we are only left this bad, so we have to put it like this. So basically we have to return this. So what is unique about anagrams? Not unique, but kind of a property. So that property is that all the letters, right, that we have inside of an anagram, for the other anagram these letters are same, right? So in the case when we have a b c d, a b a c d, and b a c d a, so I can see a appears two times here inside of this string, right? And b appears one time, c appears one time, d appears one time. Now if I take all these frequencies and make another word, right? So if I make for this, I will get for B, I can see frequency is 1, A it's 2, C it's 1, T it's 1. So I can see the frequencies of each and every letter is same because it's just not, it's nothing but just a permutation. So that means these are anagrams. So basically the frequency of all the letters inside of them are same. So that makes us arrive at a approach where we can say that, all right, I am saying that all the characters are going to be same, right? So this way it's very difficult to know, right, if eat and t and 8 are the same thing. But what if I sort this, right? If I sort this string, right, what do I get? I get a, e and t. If I sort this t string, I get a, e, t. If I sort this, I get a, e, t. So you can see if I just sort these strings, right, and let's say I store them inside of a map, right, I hash them, then it will be very easy for me to know what are these anagrams, and I'll be very easily able to group them, correct? So that is the first approach that we are going to do here. That is, first we'll start iterating in this strs string, strs vector, and then for each string inside of this vector or array we have to sort that particular string, right? And then we will store it inside of the map. So now how are we going to store inside the map? So first thing is that here we'll take a string, right? And then the next thing we will take will be a array here, all right? Array of string to store these, right? Eat. Now AET will be stored here. That is AET is stored here. Now AET is coming from which string? Eat, right? So in the answer I have to written eat, not AET, correct? So I have to put EAT. And similarly for AET we have T and 8. So T and 8 we will store as an array here, right? So this is basically the approach that we are going to do. So then again for tan, if you see, I'll get a and t here, correct? So I'll store a and t, and with this I'll store tan, and the next thing that I'll store is nat. So I've stored both of these, and then bat, I can see it will be abt. So with abt I'll be storing bat. And then after we are done iterating in this array of strings, we can simply iterate inside of this map, and for all these values right inside of the map, I can take this vector out. So I'll simply take my vector and put these inside of it. So t e a 8 tan and nat and bat, correct? So this will return. So this is the answer. Now I hope you have understood this approach, and it's pretty easy to implement as well. But if you see the time complexity for this approach, it would be let's say, so first of all, let's say strs length is n. Okay, so we are iterating in it, and with each iteration what are we doing inside of this is we are sorting these strings. So let's say all of these are going to be variable length, right? So let's say it's m. Okay, so we are sorting them, so it will take m log m time, correct? So basically what we are doing is we are taking n into m and log m time, correct? So this is the time complexity for this case. And space complexity, you can see it's simply for this map, and at max there will be, each and every string will be unique here, right? So we'll not be able to find anagrams, so we'll have all the strings of strs stored inside the map, so it will be big O of n here, right? So that will be the space complexity. Now can I reduce this time complexity, right? So I definitely can. I can get rid of this log m. Now how can I get rid of this log m? So we can see that these strings are made of lowercase English letters. So that means my string will have letters from A to Z, right? So if my string has letters from A to Z, then that means it can have at most 26 types of characters. So instead of trying to sort this, what we can use is something called count sort, right? But we're not going to actually sort this using count sort. Instead of instead of that, what are we going to do is we are going to only store these frequencies, right? So what I'll do, I'll create a 26 sized array or map, whatever you are comfortable with, you can form that. And let's say I'm forming array here, right? So we'll have 26 cells, and this represents A, B, and C, D, and up to Z. So we'll have these, and we will store the frequency. So for eat we will have the frequency as 1 here. So here we'll have 1, and we have t. So let's say somewhere here I have 1, correct? So now these frequency arrays will be same for anagrams, correct? So instead of storing this string here, I can store this, right, this frequency array. And using this frequency array, as we saw when we were discussing how to find anagrams, the number of elements are first of all same, and the frequencies of all the characters are also same. So using this frequency array, we'll be able to find anagrams without having to sort these, correct? So we get rid of this log m. So after this, what I have to do, I will go inside of the string, and for this m length I will do only one iteration to make this frequency array. So my time complexity will become nm in that case. So I hope you are getting it. Let me write it clearly here. What I'm trying to say, I am saying we have these all strings, right? and we have to group them, correct? So I'm saying instead of trying to sort this, what we can do is we can simply take the frequencies of it, right? So let's say this is the container that I have to store the frequency. So for A it's 1, for E it's 1, for T it's 1 again, right? So if all of these are 1, so for this also if I check, the frequencies of these letters are going to be the same. E will be 1, T will also be 1, right? Similarly for 8, if you see, it will be same, correct? For T1, right? So that means these are anagrams of each other because their frequencies of each and every letter is going to be same. So that is, if I simply store this, right, then also I'll be getting an answer. So there is no as such need to sort the strings, right? So instead of that, I can simply take the frequency. Now why am I able to take these frequencies is because I only have 26 characters, right? So at most the length of this will be 26 only, and this way I will be able to minimize my time complexity. That is, I'm able to minimize it by this factor log m, correct? So now my final time complexity will become big O of nm. So now let us, I hope you have understood it. Now let us go ahead and code it, then it will be more clear. Okay, so first what I'll do is I'll first declare the vector of string answer in which I'll be storing, but later on. Now what I have to do, as I said, I'll be iterating inside of this strs array. So I'll send I is equal to 0, I less than strs dot size and I plus plus. Now I have to iterate in it, and what now I'll do is, let me create the map here, right? So inside of that map, see, we need the map, and map we need to group the anagrams, right? And inside of the map, the very first value will be the frequency array, because for each and every frequency array, if they will be same for anagrams, correct? So that is why we are able to do this. So I'll take a vector of integer here, right? So where we will have to, the length of this vector will always be 26 because we have at most 26 characters, and this is our frequency array. We are going to store the frequency array in the first value of the map. In the second value of the map, I have to store the vector of string, right? All the anagrams which are having the same frequencies of all the letters inside of them. So I'll create this map, and after this what I have to do, I have to take my strs of I, right? So I have to iterate in this particular string, right? So ith element of this strs. So before that, let me declare int frequency array, and its size is going to be 26. Now I'll start iterating inside of, well, let's say char c in strs of I, right? So for all the characters that are present inside of this string, right? So that we will be storing inside of our frequency array. So we'll say frequency of c minus a. So what this will basically do is, let's say if this is a, so a minus a is what, 0. Let's say this is b, so then b minus a will be 1. So at these indexes I will be storing an integer which will represent the frequency of this particular character c, right? So I'll do this. So at this particular index, whatever be the value, so initially all these values will be 0, and we will keep incrementing them as we find them along the iteration. And after this, my frequency array will be created, and now I can simply put this inside of the map, right? So I'll say mp of this frequency array, and for this particular frequency array I have to insert this string of strs of I. So this particular string I have to insert, correct? So I'll say pushback strs of I. Now what this will basically do is, if the frequency is similar, right? If these containers that we have created, these are similar. So for it is similar. So what will happen is, let's say for this particular frequency, so let me make this container only. We have this container as our identifying block for the anagrams. So with this I will store eat and t and 8. So this is what is going to happen, correct? So now I have created the map. So this is basically what we have to do. After this I have to simply iterate inside of the map. Dot it in map, and all the second values we have to insert in our answer, right? So because what will happen is we will be having something like this, right? So instead of this AET we would be having this container frequency array here. So all for all these values, right, for all these values I have to take the map of second values that are going to contain these groups of anagrams, right? And we'll simply put it inside of our answer. So I'll say ans dot pushback, and I have to push back it dot second because it has group of the anagrams, and here I can simply return my answer. So that is the whole logic for the problem. Now let us quickly run it. So it's accepted. So this is basically how you have to solve this question.